If we have a piece of algebra, something like, say, 2x plus 3, that, as it stands, just a piece of algebra, no context, not equal to anything, is an expression. Okay, but if we now set that equal to something, if I tell you that that piece of algebra, remembering of course that x stands for a particular number that we might find out at some point, we might not. If I tell you now that that is equal to, say, 11, in being equal to something, it's not an expression anymore, it is now an equation. Because this now reads, there is some number that we're using x to stand for. When we times it by 2 and then we add 3, we will get exactly 11. And we can go through some sort of process to work out what the value of that missing number is, what the value of the x is by solving. Now imagine instead that we had the same piece of algebra, the 2x plus 3, and I told you that that was equal not to a number, but to something like, say, the total. The total of what? Well, who knows? It doesn't really matter. But say that to find the total of something, we took this number x, which presumably in this case represents not just a number but a quantity, a changing thing, maybe something like the number of tickets sold. To find the total, we would then times it by 2 and add 3. Why? Because that's just what we need to do for this way of finding the total of whatever it is that we're finding the total of. This is an example of a formula, a kind of rule, sort of an equation, but rather than being equal to one particular thing, rather than one particular number, being equal instead to a quantity, something like the total or say the number of people or something like that. We've kind of come across formulas before. We've got the idea of the formula of formulas to find, say, perimeter. To find the perimeter, we add up all the sides. Find the area of a rectangle. Say, if we've got the width and the height. To find the area, we know that we're going to times those two numbers together. The width times the height. That is a formula, a rule to do something. We could make that look more algebra-y by using letters. Why don't we say A equals W times H, just to make it look a bit more like algebra. But that's a formula again. A process that we can go through where we can change the values of W and H, and we're going to get a different value of area in this case out of that formula. But the rule stays the same whatever the numbers are. If we consider just a generic formula, this is just a completely made up one. T equals 4x minus 10. What are t and x? Who knows? It doesn't really matter. T is something, and to find t, we'd take the value of x, times it by 4, and then take away 10. It doesn't matter what t is, it doesn't matter what x is. But the way this rule works, we take our x, we times it by 4, we minus the 10, and that gives us the corresponding value of t, for whatever x and t are. I could then tell you that x stands for a particular quantity and t stands for a particular quantity. It doesn't really matter. Now, the t, in this case, is said to be the subject of the formula. It's what the formula is about. This is a formula designed to find t. You put the x in, you choose the value of x, or you discover the value of x, or whatever. You input the value of x, and it outputs a value of t. X goes in, and t comes out. With this formula happening in the middle. X goes in, and t comes out. T is the subject of the formula, because it's what the formula is about. But there is a clear link between t and x. They are linked by this formula. You put x in, you get t out. But imagine that we had this the opposite way round. Imagine that we knew the value of t. We knew the output value. We wanted to know where it had come from. We wanted to find the value of x. Imagine though, we didn't want to just do that in one particular case, because for one particular case, we could just set the value of t to whatever our answer is and solve it. But imagine if we didn't want to do that. Imagine if we wanted to switch the formula around so that we could put a value of t in and get a value of x out. So we'd have to effectively reverse the whole formula. And a question could ask us to do that. The question could say, make x the subject of t equals 4x minus 10. So currently, again, the subject of this formula is t. It's what the formula is about. And we can use x to find t. But imagine if we wanted it the opposite way around. Imagine if we wanted to switch this round. Imagine if we had all the values of t and we wanted to find the values of x that had originally been put in to generate those t's. Well, we'd have to reverse the whole formula. And it comes back to this function machine idea, because the idea of a function machine, it reverses the steps that have been done to get back from a total to the original input value. We can do kind of the same thing here. So what we do is we first take note of which letter we are trying to make the subject. This is the letter that we are trying to make the subject. So we're going to build our function machine first. We're going to start with the x. We're going to start with the one that we want to make the subject. And we're going to draw our machine, and we're going to write down what happens to it. So the first thing that happens to the x, it becomes a 4x. So it times is by 4. The second thing that happens, we take off the 10. And this time, rather than spit out a single numerical total, it spits out a whole range of totals. It spits out the idea, this quantity t, whatever that happens to be. So it doesn't spit out a number this time, it spits out another letter, a quantity, this idea of t. Now what we need to do is reverse the function machine, much the same as we did before. So t goes back in. T was our original output. T is now the input. Instead of taking 10, we are going to add 10 on. And instead of timesing by 4, when we're reversing, we're now going to divide by 4. So we're going to go in. T goes in. We add 10. T add 10 is going to give us just that, t plus 10. And then we're going to divide all of that by 4. Well, we can't go too complicated on this. T plus 10, and then all of that is going to be divided by 4. Looks a bit complicated, I accept. But that is going to be the case. It's just another formula. So we're now saying that x is equal to t plus 10 divided by 4. Again, we don't know what x is, we don't know what t is. We're never going to find out. X could take any value, in theory. T could take any value that then matches with it. This formula starts with an x. X goes in, t comes out. This formula starts with a t. T goes in, x comes out. We've made x the subject of the formula. The subject was t. The subject is now x. We'll use different letters this time though. So we'll make b the subject of a equals b minus 10 and then all divided by 15. The subject of this formula currently is a. This is a formula that inputs b and outputs a. It is a formula, a rule of some sort to generate values of a, whatever a happens to be. We now want to make b the subject, so we're going to start with our b. We're going to build the function machine and write down what happens to b. Well, the first thing that happens to b, thinking about our BODMAS, b take 10 divided by 15, so the first thing that happens is the minus 10. The second thing that happens is we divide by 15, because we've got b take 10 and then divided by 15. That outputs that value of a. A letter this time again because it's a formula, a rule, rather than outputting a single value. We now want to reverse our function machine, so the a goes back in. Instead of dividing by 15, we now times by 15. And instead of taking 10, we now add 10. When we put a back in and we times by 15, that gives us 15 lots of a. and then we add 10 and we get 15a plus 10. Notice that they won't combine anymore. Different currencies again. We've got a term with letters in and a term that's just numbers. There is no way we can simplify those anymore. But there is our original. There is our output now when we reverse the machine. So we can say that b and this must be the same. So b equals 15a plus 10. And we now have a formula that inputs a and outputs b. And b is now the subject of the formula.